I'm super excited to welcome you to this session on elevating your IoT security with AWS's multi-layered security approach. I'm Ryan D'Souza, and I'm an AWS IoT solution architect. Let's go ahead and take a look at the agenda for today. We'll cover common IoT use cases and security challenges. I'll discuss AWS's multi-layered security approach, principles, and services. We will apply the principles to a consumer IoT use case. We'll then apply the principles to an industrial IoT use case. I'm going to show you a demonstration of how to detect a device anomaly and how to take a mitigation action. And we'll finally conclude with some next steps on getting started. So before we jump into IoT security, what are customers doing with AWS IoT? From connected health to smarter homes, smart buildings, smart cities, smarter factories, AWS IoT is used across industries to enable digital transformation in consumer, commercial, and industrial applications. So most of you already know about our AWS IoT services, but here is a quick recap. It's divided into three main areas. There is software that runs on devices, there's connectivity and control services, and analytics services. So let's take a look at some of the challenges associated with IoT security. The first is an increasing number of connected devices. IDC estimates that there will be 40 billion devices connected by the year 2025. So there are a large number of IoT devices that need to be secured. Second is that traditional software and security, such as firewalls and antivirus software, is no longer sufficient. In many cases, antivirus software cannot run on constrained devices. Third is an IoT solution is made up of many different solution components, often provided by many different vendors. And this leads to ambiguity with ownership of the security solution. With IoT, you're dealing with constrained devices. So devices with low CPU, low memory, and low disk. So we need to find a way to secure constrained devices. And finally, many IoT devices are often not secure by design, and new attack vectors are constantly emerging. So we need a way to monitor, alert, and apply security patches. To address these security challenges, you need a platform to securely onboard and manage IoT devices at scale. So the best IoT solution offers multi-layered protection from device to edge to cloud. And AWS recommends applying security at all layers using defense in depth with multiple security controls and services in order to identify threats, protect against them, detect anomalies, respond and mitigate, and finally recover. And recovery is not just about data, it's about entire infrastructure and applications extremely fast. So now let's take a look at some common IoT security principles. The first is unique identity with credentials. So you need a way to generate, rotate, and revocate credentials. Prefer to use secure network communication protocols when available. Use policy-based authorization with the principle of least privilege. Have a mechanism to patch and apply security updates to devices. Remotely connect to devices securely and secure onboarding. Encrypt data in transit and at rest. Have continuous auditing and monitoring. And have a plan in place to remediate and recover if needed. So the first service we're going to take a look at is called AWS Iot Core. And AWS Iot Core is a fully managed service to securely connect to devices and ingest data. AWS Iot Core uses the AWS IoT security principles. So unique identity, every device is given a unique identity with an X.509 certificate or using custom authorizers. There's mutual authentication between the device and Iot Core. So the device needs to authenticate with the service and the service needs to authenticate the device. Use IoT policies for fine-grained authorization. Use TLS 1.2 to encrypt data in transit. Use MQTT over specific ports of 8883 and 443 to limit the number of ports that need to be opened. The connections are device-originated and not cloud-originated and have continuous logging, monitoring, and alerting. So the next service we're going to take a look at is AWS IoT Greengrass. So Greengrass is used to process data at the edge and for edge analytics. and Greengrass uses the same security principles of AWS IoT. Greengrass uses connectors in order to connect with applications, third-party applications and services like Splunk, ServiceNow, and Twilio. And these connectors need a secret to authenticate with the third-party app or service. AWS IoT Greengrass lets you authenticate with services and apps from devices without hard-coding passwords, tokens, and other secrets. And Greengrass extends Secrets Manager, which is a cloud service, to the edge onto devices. And the secrets used in Greengrass are encrypted in transit and at rest. Next, let's talk about AWS IoT Greengrass hardware security. So you need a mechanism in place in order to protect the private keys that are used in Greengrass in order to prevent an attacker from impersonating the device that is running Greengrass. As an additional layer of security, AWS IoT Greengrass offers customers the option to secure and protect the private keys in a hardware secure element. So you need a device that supports hardware secure element, and we have a number of these devices in our partner device catalog. And the secure elements use PKCS11 standard APIs to integrate with AWS IoT Greengrass. So let's say you need to troubleshoot an IoT device. How do you connect to this IoT device that is behind a secure firewall? How do you connect to this device without changing any existing firewall rules? You can use the secure tunneling service, which is part of AWS IoT Device Management. With secure tunneling, you can establish a bi-directional communication to the device over a secure connection that is managed by AWS IoT. And you can configure a tunnel timeout to shut down the tunnel after troubleshooting. Secure tunneling now supports a new capability called multiplexing, where you can establish multiple connections to the same device. So we discussed earlier about the need to apply software updates to IoT devices in order to patch security vulnerabilities. AWS IoT Device Management Jobs allows you to apply software and firmware updates to patch security vulnerabilities and improve device functionality. And you can use the code signing feature to sign code before deploying software on devices. AWS IoT provides you with fine-grained device logging and monitoring, and you can configure different log levels. This means that you can collect only the data that you need for your security investigations. So assuming that you've done all of this, how do you keep your IoT devices secure on an ongoing basis? AWS IoT Device Defender is a fully managed service to secure your fleet of IoT devices. With Audit, you can audit the policies associated with your devices to ensure that they're not deviating from security best practices. And Audit comes with 14 security best practices. With Detect, you can detect device anomalies. And with Alerting, you have the capability to alert through Console, CloudWatch, and SNS. And finally, you can take mitigation actions, such as revoking certificates, revoking permissions, pushing software security updates to devices, quarantining a device if needed. And I'm going to show you a demonstration in which I'm going to show you how to detect a device anomaly and how to take a mitigation action. So a new feature that we launched at reInvent is Device Defender ML Detect. And this is an enhancement over the Detect feature. It makes it easier for customers to get started with Detect. Machine Learning Detect, or ML Detect, uses machine learning on metric data in order to model device behavior. And once the model is active, you can start monitoring for device anomalies and take mitigation actions. So next, let's discuss how do you secure your IoT workloads in the AWS cloud? How do you detect and respond to malicious activities? Guard Duty is a threat detection service that enables you to continuously monitor and protect your AWS account's IoT workloads and data. It analyzes VPC flow logs, DNS logs, and CloudTrail events. It uses threat intelligence and machine learning to identify threats more accurately. So let's recap the key elements of AWS IoT security. You can use AWS IoT and IAM for unique identity and credentials. Use the security features available in MQTT and HTTPS. Use IoT policies and IAM policies for fine-grained authorization and access control. have a mechanism to apply security patches, and remotely connect to devices securely, including secure onboarding. And you can do that with device management and systems manager. Encrypt data in transit using TLS 1.2. Use KMS keys to protect your encryption keys. Have continuous auditing and monitoring with CloudWatch, CloudTrail, Device Defender, and Guard Duty. And use IoT device management, Device Defender, and SNS in order to alert and take mitigation actions. So security has always been job zero at AWS. It is baked into everything we do. We have a lot of customers using the AWS platform, and what this means from a security perspective is that we can take the lessons learned and bring it back into improving the security of the platform. When building IoT applications on AWS, customers can improve their ability to meet core security and compliance requirements, such as data locality, data protection, and confidentiality using the AWS multi-layered security approach. When building IoT applications on AWS, it is important to understand the shared responsibility model, where security and compliance is a shared responsibility between AWS and the customer. And the differentiation of responsibility is often referred to as security off the cloud versus security in the cloud. So the customer is responsible for their applications and data in the AWS cloud. But AWS provides lots of prescriptive guidance to make this task easier for customers. So now let's apply the security principles that we have just learned to use cases. The first use case we'll take a look at is a consumer IoT use case, and this is a smart home use case. So this is a smart home with a number of smart devices. We give every smart device a unique identity using an X.509 certificate. We use AWS IoT to securely connect to these smart home devices and ingest data. We use the security features available in the MQTT protocol. If we need to troubleshoot one of these smart home devices, we can use AWS IoT device management tunneling feature that we discussed earlier to securely connect to the device that may be behind a firewall. If we need to apply security patches and security updates on these devices, we can use AWS IoT device management jobs. As you can see here, we're using the Device Defender ML detect feature in order to model the normal device behavior of these smart home devices. Once the model is active, we can start monitoring these devices for anomalies. Let's say that one of these devices is participating in a DDoS attack and starts sending a large number of messages to the platform. Using AWS IoT Device Defender Detect, we can detect these anomalies and we can take mitigation actions. We can send off SNS alerts. We can place a call to the customer using Amazon Connect. We can quarantine these devices, and we can even disconnect the device from the platform by revoking its certificate. Let's take a look at another use case. In this case, it is an industrial IoT use case, and this is a smart factory. So this manufacturer is looking to improve operational efficiencies, reduce unplanned downtime, and improve product quality. And as you can see in this architecture, we're using the ISA 95 model of different layers. At layer 0, you've got equipment and sensors. At layer 1 and 2, you've got industrial automation systems and supervisory control and data acquisition systems. At layer 3, you've got manufacturing execution systems and historians. You can also see that at layer 3, we have placed the edge gateway running Greengrass, so we can process data locally at the edge. Layer 4 and 5 is your enterprise applications. So the first thing we need to do is to secure the OT-IT network boundary. And how do we do that? As you can see in this architecture, we've introduced an IDMZ, or an industrial demilitarized zone, in order to protect the OT-IT network boundary. And that's between layers 3 and layer 4. Let's take a look at some of the other aspects of this architecture. Industrial control systems have traditionally been air-gap systems and have used legacy protocols and insecure protocols. As you can see in number 1, we're using a protocol converter to convert the insecure protocol into a secure protocol such as MQTT or OPC UA. In number 2, we connect the insecure protocol, for example, Modbus, directly to the edge gateway running Greengrass. In number 3, we're using secure protocols such as MQTT or OPC UA. In number 4, we're connecting a device directly to the edge gateway, and we are placing an X.509 certificate on the device as such that it can support the MQTT protocol. So we are sending MQTT messages directly from the device to the edge gateway. Number 5 is an edge gateway running Greengrass. In this case, it is a Snowball edge device. Number 6, we've got AWS Outpost that runs industrial applications at the edge and runs AWS IoT Greengrass. There are different ways in which we can connect a smart factory to AWS securely. You can see that in number 7 using site-to-site VPN or direct connect. At number 8, we've got a VPC endpoint, and VPC endpoints enables customers to privately connect to supported services without requiring a public IP address. If you do need to traverse the public internet, you can use the TLS proxy and a firewall in order to securely traverse the public internet, as you can see in number 9, in order to connect to AWS IoT services that is shown in number 10. I am now going to show you a demonstration. And in this demonstration, I'm going to show you how to identify a compromised device that is using a shared certificate. I'm also going to show you how to detect device anomalies and how to take a mitigation action. And please stick around after the demo, as I will be sharing with you some great resources and tips on getting started. I'm now going to show you a demonstration of AWS IoT Device Defender, a fully managed service that helps you secure your fleet of IoT devices. We're at the AWS IoT Management Console, and you can find Device Defender under Defend. The two things you can do from here is you can either set up a new audit in order to audit the policies on your IoT devices, or you can set up a monitoring activity in order to monitor your devices to detect anomalies. Let's first go ahead and take a look at Audit. So with Audit, you can continuously audit the policies associated with your IoT devices to make sure that they aren't deviating from security best practices, and alerts you if something goes wrong. And we can create a new audit. AWS IoT Device Defender Audit comes with 14 security best practices that you can select and run as part of an audit. And these are the 14 different security best practices. So things like, are your device certificates shared? Are your IoT policies overly permissive? Is the CA certificate going to expire? Is the device certificate going to expire? And many others. You can set up the audit based on a schedule. So you can either run it once or set it up on a schedule that you choose. I'm going to go ahead and set it up to run once. So as you can see, the audit is now in progress, and there are all 14 checks that are being done. So the audit has now been completed and the status is non-compliant. So I have some devices that are not complying with AWS IoT security best practices. 2 of the 14 have failed compliance. Let's go ahead and take a look at which ones. You can see here that I have some devices that are sharing a device certificate and conflicting MQTT client IDs. If I take a look at the device certificate which is being shared, I can find here the things that are sharing the device certificate. So I have 2 devices, reInvent 1 and reInvent 2, which are 2 devices that I set up earlier. And these devices are sharing a device certificate, which is against the AWS IoT security best practice. The next feature we're going to take a look at is going to be AWS IoT Device Defender Detect. So with AWS IoT Device Defender Detect, you can detect anomalies in device behavior that may indicate a compromised device by monitoring the incoming device metrics and data and comparing them against expected device behavior that you define by creating a security profile. At setting up security profiles, there are 2 ways to do that. One is a rule-based security profile, where it is your responsibility to set up a security profile for the normal behavior of your devices. The second is an automated way, which is a machine learning based detect profile. The first one we're going to take a look at is rule based. So we give the security profile a name. We can see here there are different metrics. There are cloud-side metrics as well as device-side metrics. So the one we're going to select is messages sent. We give it a name. And we can select here either absolute value or statistical threshold. We're going to say less than and 50 messages every basically 5 minutes. Okay, so in this way over here, you can actually set up define the normal behavior for your IoT devices by setting up a security profile using role-based. We can select an SNS topic. So we're going to pick reInvent 2020. We need to give it a role so that AWS IoT Device Defender can access SNS. We can then pick the devices. So we're going to say all things. So there you have it. We've just set up our first security profile, reInvent Demo 1, which is using a rule-based security profile. So another way to set up a security profile is using a machine learning-based security profile, and this is an enhancement over rule-based security profiles. We need to first select the target group of devices. We give it a name. You can see here there are 6 different metrics that ML-based model is based on: authorization failure, connection attempts, number of disconnects, message size, and messages sent and received. At the metric behaviors, suppressed notifications or not suppressed. I'm going to say not suppressed for the first 2, and I'm suppressing notifications for the remainder. You also have ML confidence level of high, medium, and low, and this is the sensitivity of your ML model. So high confidence level means low sensitivity and lower number of alerts. Medium confidence is medium sensitivity, and low confidence is high sensitivity and higher number of alerts. So let's say medium sensitivity, and high confidence level for the remainder. Like before, we're going to set up an SNS topic. So we pick the SNS topic as reInvent 2020. We need to pick a role, and we say create. So there you have it. We now have set up a reInvent Demo 2 security profile, which is an ML-based security profile. And we can go ahead and take a look at the training report. So as you can see here in this ML model training report, the model status is pending build because we've just set it up. So the model has not got enough of training data to do ML detect. So here you have the number percentage of training days and the percentage of training data, and you typically require 14 days and 25,000 data points in order for the ML model to be active. Let's go ahead and take a look at some other security profiles. So here we have another one called ML Detect profile, and we take a look at the training report. Oh, so this model is actually ready. The model status is active. It's got 100% of data. It's got all the data it needs in order to train the model, and the model now is active. Let's go ahead and take a look at alarms. We can see here that there are 5 active alarms for these devices. And this was based on the ML Detect profile that is active. And the threat was the number of connection attempts. So the number of connection attempts exceeded normal behavior. This was detected by the ML Detect model and flagged as an alarm. We can also take a look at history. And this shows all the alarms over the last 14 days, active alarms as well as alarms that were cleared and alarms invalidated. If we want to drill down and conduct a security investigation on one of these devices, let's pick DDML1. And we look at violations. We look at historical violations over the last 7 days. We can see here that the device sent an unusual number of messages sent, and we drill down into the number of messages sent in the last 7 days. And we can zoom into this. So you can see here that there was unusual number of messages sent, 300 messages. Normal message count was far lower. So AWS IoT Device Defender ML Detect was able to pick this anomaly up and flag it as an alarm. We'll finally take a look at mitigation actions. So through your audit, if some of your devices failed audit, or through detect, if some of your devices showed anomalies, you can then take a mitigation action. Let's go ahead and create a new mitigation action. We need to give it a name. These are the different mitigation actions. So you could, for example, add the devices to a thing group called quarantine thing group, which is what we're going to do. But there are also other mitigation actions that you can take. You need to select a role, and you need to select the thing group. So I had earlier created a group called quarantine group. So these are devices that I'm going to basically push into the quarantine group as a mitigation action. So there you have it. I've just created a new mitigation action called reinvent demo in order to send the devices into a group called quarantine group. So I'll finally start a mitigation action. I select the action, which is reinvent demo that we just created, and I confirm. And there you have it. It is success. The mitigation action has been taken. So in this demo, I showed you how to create an audit for your devices, how to create security profiles in order to detect anomalies in your devices, and finally, how to take mitigation actions. All right, so now let's go ahead and summarize what we have learned today. AWS recommends applying security at all layers using AWS's multi-layered security approach. AWS offers end-to-end security for IoT from device to edge to cloud with a suite of security services. The new ML Detect feature is an enhancement over the Detect feature. It makes it easier for customers to get started with detecting anomalies in their devices. AWS provides lots of prescriptive guidance to help customers with planning, designing, and building IoT applications on AWS. And AWS provides the easiest, quickest, and most cost-effective path towards comprehensive and scalable IoT security. So we've got tons of great resources to help you get started. We've got online training, we've got classroom training, and we've got a security certification. We've got the well-architected framework and the well-architected tool, which is a set of architecture best practices to help customers build applications on AWS. And IoT Lens is an extension of well-architected specifically for IoT workloads. We've got tons of customer success stories on our websites with examples of how customers have transformed their business with AWS IoT. A great way to get started is with our AWS IoT solutions, which are pre-built solutions across industries and use cases. I want to thank you for your time today and request you to please fill out the session survey. Thank you.